Okay, should we start now or we will wait for another 1 minute? 20 people are
Start,
joined.
sir.
Okay. Okay. So, first of all, do you have any doubt whatever we have discussed till now?
Yes, sir.
Yeah, if you have any doubt, tell me. Anyone?
Sir, in moment, sir, in the previous PPT which you have sent, sir, example number 2, sir, you were taking moment at C. I got confused, sir. And now you are taking some moment at C equals to 0, then minus MC. Also, you are considering, sir, that one, sir. I have a bit
I
confusion in that
no
one.
no example 2 we have not discussed yet in detail, right? Till
Yes, sir.
example 1 only we have discussed, means influence line diagram for reaction only we have discussed. Okay.
Yes,
Okay.
sir.
Please mute someone there is I think unmute, please mute, some background noise is coming. Okay. Anyway, let us start with this. Any more doubt? Moment influence line diagram we will discuss today. Any other doubt? Anyone? Anyone? Do you have any doubt? Okay, then let us start. See, let us start with this one today. Construct the influence line for the moment at point C of the beam. In the previous class, we have started discussing about this, but we could not complete. Let us step by step try to understand how to construct the influence line diagram for moment. Okay, at a particular point in a beam. Now, as you have seen, in case of finding out the influence line diagram for reaction at A, what we have done initially, we have found out the reaction at A for the different position of the load over the beam, right? And what is that load? The load is basically the unit load and of a dimensionless quantity. So basically dimensionless unit magnitude of load we were passing through the beam, and because of that, at different position of the load, whatever reaction is being generated because of the different position of the load at support A, if we have plotted it, that is actually the influence line diagram for reaction at that support. Exactly the same philosophy we will be doing for finding out the influence line diagram for moment at a particular point C. So, you see, if we want to find out the influence line diagram for a particular point C for a simple supported beam, this beam is a simple supported beam, and you can observe that the point C is at a distance 5 meter from the point A, and where the length of the beam is 10 meters. So basically C is, in this case, C is the midpoint of the beam. Now if you want to find out the influence line diagram for this beam, what you will have to first do? You will have to first find out the moments at different position of this beam because of the load being moved over the beam. So that means, if you remember in the previous class we have started with this discussion. Let's say if you see that there is a load, see, this is the unit load, let's say this is the unit load which is just now the outside of the beam. So if this load starts moving and then it enters the beam at this point, and then gradually if it moves, then what will be the moment at point C at different position of this load, you will have to find out. That means, you see, should be very clear, there is a clear difference between your bending moment diagram and influence line diagram. I have explained it earlier also. Here you see here you observe the difference, although you may be finding the shape of the influence line diagram and shape of the bending moment diagrams are same, but no, they are not the same thing. You should understand it very clearly. So here you see what we are doing here. In case of bending moment diagram at C, what you do? Generally you put the load over here and then you find out what is the bending moment at C. But no, in case of influence line diagram, you see the load is not static, it is a moving load. So you see what you have to do. Suppose the load enters first through from this direction and it reaches the support RA, that means it just entered the beam. So because of this position of the load, what is the bending moment at C, that you will have to plot first. Okay. Now if you move the load little bit further, so if you bring this load over here, then because of this position of the load, what will be the bending moment at C, that you will have to find out. Then you see again you move the load little bit further, your load is moving, your load is moving. So let us say you are bringing the load to here, the load is coming over here. So because of this position of the load, what will be the bending moment at C, you will have to find it. Then what will happen, this load will reach the point C. So exactly when this load is over the point C, what is the bending moment at C, you will have to find out. Then gradually what will happen, this load will move further, it will go here, then at this position of the load also you will have to find out what is the bending moment at C, and gradually it will go and it will reach this support RB, and finally this will move out of this beam. Is it clear? So for every position of this load, for every position of this unit load, which is of dimension, which is basically dimensionless quantity, dimensionless unit magnitude, you will have to find out what are the bending moments at C, and if you plot that, then you are going to get the influence line diagram for C, influence line diagram of the bending moment for the particular position C in the beam. So how do you do it? So the first thing you should understand, for generating bending moment at any point, generating the bending moment or finding out the bending moment at any point, what you need to do first? First you need to find out the reaction. So let us say the load when it reaches over here, then what will be the reaction RA over here? So you have found it out. So the load is of unit magnitude. So the load is basically of unit magnitude. So your RA is going to be 1 in this case. When the load is just over this, then what will be the reaction at RA? So RA is going to be, in that case, your RA is going to be, your RA is going to be equal to 1. Is there any doubt on this? Is there any doubt on this?
No, sir.
So if RA is 1, then what will be the moment at M? Or what will be the moment at C? So what will be the value of MC in that case? So what will be the value of MC? That you should be very clear about. What will be the value of MC? Tell me. So what will be the value of MC? Bolo? So how much is RA? RA is 1, right? And what is the distance between this point and this point? This is 5 meter, right? So this multiplied by 5 minus 1 multiplied by 5, correct? Because reaction multiplied by this distance, that is going to create a moment over here, and also this load is acting over here. So load multiplied by this is going to create a moment over here. So this is equal to 0. Is there any doubt on this? Is there any doubt on this? Okay?
No, sir.
Okay. So you see, so basically when the load is placed over this point, your moment at C, very clearly understand this, very important. This moment at C is going to be equal to 0. Now let's say let's say, as I have shown you in this example also, just go to, let us go to this, sorry, where is it? Yes, here. So you see, if you go to this table, forget about this, okay, just see this one. So you see, at 0 moment is 0. So at 2.5 what will happen, you tell me. So let's say the load starts moving, and it reaches a distance here, and this distance and this distance and this distance, let's say up to this distance is, instead of x, let us write it is 2.5. Is it okay? This 2.5. So if this load reaches over here, then you tell me what will be the reaction over here. What will be the reaction? Tell.
Sir, RA into 2.5.
Yes, sorry, Control Z. Let us write it on the top, okay? I am writing at the top. RA
into 2.5
into 2.5, okay?
and
RA into 2.5 reaction.
Yes,
you will have to find out the reaction at A. What is the reaction at A? Unless you find out the reaction at A, you cannot find out the moment at C, right? So how do you find out RA? So you will have to take moment about B, right? You will have to take moment about B, isn't it? You will have to take moment about B. Then only you will be able to find out what is the reaction at A. So for finding out reaction at A, what you will have to do? See, we have done it. If you remember, we have done it in the previous class. Reaction at different position of the load. If you remember, when we have discussed about this problem, haven't we done it? We have done it, right? So what will be the reaction? We have found out in the previous class. So when the load is moving, yes, so it is going to be 0.75. Is it or not? It will be 0.75, right? So if you see, it is very simple. RA into this distance is how much? From A to B the distance is 10. So RA into 10, right? Minus, or RA into 10 is equal to, if you see, 2.5 multiplied by, sorry, not 2.5, 1, load is 1 multiplied by, what is this distance? What is this distance? Distance from here to here. What is this distance? Tell me.
7.75.
7. Not 0.75. It tells 7.5.
Yes,
7.5. Okay. So your RA is going to be equal to thus your RA. Sorry. Your RA is going to be, so RA thus is going to be equal to 7.5 divided by 10 is equal to 0.75. Now is it clear? So you have found out the reaction now. So once you have found out the reaction RA, then you find out what is the moment at C. So how do you find out moment at C in that case? So if you want to find out moment at C exactly the same way, then you apply the method. What is the moment? So moment is going to be equal to how much? Tell me. So clockwise, anti-clockwise. You tell me. So RA into RA. What is the value of RA? 0.75 multiplied into
2.5.
2.5 or 5. You are taking moment about C.
Sir, 5.
Yes. Why are you getting confused? So see, from A to C the distance is how much? The distance is 5, right? Minus 1 into how much? 2.5. Why it is 2.5? From this load to this point the distance is 2.5. Is it clear to everyone?
Yes.
Or if you you see, this is very important. You should be very, very clear about this. So from here to here the distance is 5, right? From here to here the distance is 5, and you see from here to here the distance is how much? From here to here the distance is in this case 2.5, isn't it? So this is 2.5. So 1 multiplied by 2.5. So one should not get confused. This is actually, this distance is 2.5, load is actually the unity. Okay. So what is going to be your value of MC? Tell me.
1.25.
It is coming
1.25.
1.25. Yes, that is correct. So basically MC is going to be 2.5 divided by 5 multiplied by 0.75, right? So it is going to be 1.25. Okay. So is the sign okay or sign is wrong? You tell me. Whatever sign we have taken, is it okay?
Yes, sir.
It is minus 1.25 or plus it will come?
Sir, plus coming.
Plus.
Yes, sir.
2.5, just a minute. So CALC, if you take, then it is 2.5.
7.25.
2.5 divided by 5 equal to divided by 0.75, right? 0.75, right? Is equal to 0.66. It is coming.
Sir, why we will divide? Because we have taken moment at because
sorry, I am just doing mistake. 0.75 into 5, right? Equal to this 3.75 minus 2.5. Is it okay? 1.25. Okay, perfect. So see, MC is going to be 1.25. Is it clear? Everyone, is it clear? Now you see, suppose you move this, see that then you go to the PPT, then you go to the presentation, you see. So what you are finding out? At 0 the moment is 0. When the distance, when the load is placed at 2.5, your moment is 1.25. Now let us move the load to this, from here, from here to here. Let us move this load to from here to here. Okay. So what is this distance now? What is this distance now? If I am bringing this load over this, then what is the distance? Tell.
5.
It is going to be 5. Okay, very good. So it is going to be, so I delete this, okay, otherwise it is coming again and again. So let's say this is actually 5, right? And your load is unity, right? Your load is the unit load. So when this load is placed over here, what is the reaction? In the previous class, you see, we have found out when finding out the influence line for reaction. So when it is 5, what is the reaction at RA? What is the reaction at A? 0.5. Okay, correct? Yes, in the previous class we have found out. So the reaction in that case, when the load is at 5, so when the load is at 5, the reaction will be RA is going to be 0.5. So if RA is 0.5, so that means when the load is at this position, then this RA is going to be 0.5, and when this RA is 0.5, what will be the value of MC? Tell me, what will be the value of MC?
0.5.
No, you tell me the equation, otherwise you will not get.
0.5 into 5.
0.5 into, what should I write? 5. Yes.
Minus.
Next minus.
Minus 0.
1
1 into 0, sir.
Yes, very good. So 1 into 0. So what will be the value? 2.5. Are you getting it here? Let's go to this presentation and see. Sorry. Where is it? Yes. So you see, at 5 is it 2.5? At 5 is it 2.5? Are you getting? So
Yes,
you
sir.
see, what have you done? What we are doing? At different position of the load. So you see, now I am just bringing this table. Over here. Okay. See what we are doing. So if you see what actually we are doing, at different position of this load, So when it is at 0, we have found the bending moment at C is 0. When the load is at 2.5, we have found bending moment at C is 1.25. When the load is at 5, we have found out the bending moment at MC or the C is at 2.5. Now where the load will be positioned? Now let us say the load is farther moving, it will move, right? So let us say load is moving by another amount of 2.5. So that means the load is now being positioned over here. So because of that, you see this distance will now change from 5 to 7.5. So when this load is positioned at 7.5 meter distance from here, what will be the reaction at A? Can anyone tell? See, we have done it in the previous class. So you see, if the load is at 7.5, we have found out how much? It is 0.25, right? In the previous class we have discussed. So basically RA in that case, your RA in that case will be RA will be equal to 0.25, right? Now if RA is 0.25, what will be the value of MC? Now you tell me, what will be the value of MC?
0.25 into
Correct, 0.25 into
7.5.
7.5. Will it be 7.5? Where are you taking the moment?
5.
As a
Yes.
5.
5, yes. 0.2.
Because-
Don't get confused, okay? You are taking moment about this point C. You are taking moment about this point C. So RA is 0.25 and this distance is 5 meter, right? So you are taking
Yes.
moment about C. So 0.25 into 5 minus, should I write anything? Minus? Should there be any moment when you are going from left to right?
1
1 into 2.5, sir.
into 2.5.
Is
2.5.
it? Will it be? Will it be or not? Tell me.
Yes, sir.
See, we are taking moment about C and we are going from left to right. So see, the load has already crossed this section. So will this going to give any moment about this point? No.
No, sir.
If you come from this side, then this load is going to create moment about C. See, you are going from left to right. You are going from left to right. Don't get confused. Okay. So you are going from this side to this side. So you see, you are taking moment about C. Now because of the position of this load, you have found out the reaction. So is there any load acting in between this A point and C point? No. The load has already crossed this point C. Okay. So when this load has already crossed this point C, see, there is no question of this load 1 is coming into picture. So your bending moment in this case will be just 0.25 into 0.5, that is 1.25. Very simple. Okay. And you see, that's what we are getting. And we have got positive value of 0. We have got positive value of 0 earlier, and then it is 1.25. You see 1.25 at 2.5 meter. Then you see at 5 meter we have found out 2.5. At 5 meter we have found out 2.5. Then you see at 7.5 meter we have found out how much? We are at 7.5 meter we have found out 1.25. And next, you see, next is very simple again. When this load will be moving to this point, when the load will be moving to this point, then what will happen to reaction A? Bolo, what will happen to reaction A? Reaction at A?
0.
0. Yes. इतना सोच के क्यों बता रहे? डर के नहीं बताने का. It will be 0. Obviously it will
Yes,
be
sir.
0 because you see the load has moved over the support B. So the support reaction at RB will become equal to 1 and the RA is going to be equal to 0, right? So you see, in that case your RA is going to be equal to 0 and thus your MC, you see, the MC is going to be equal to how much? So when the RA is equal to 0, 0 multiplied by this distance. So if you do 0 multiplied by this 10 meter, and there is no load acting, you see, between this point A and C there is no load acting. So this is going to be 0 into 10 is equal to 0. Should be very clear about it. And you see, every point when I am writing the value of MC, see, I am not writing any unit. Have you noticed it? I have not written kilonewton meter, foot pound or anything, nothing else I am writing. Why? Because you see, this load whatever we are considering, this is actually a unit load of dimensionless quantity. So, when it is a dimensionless quantity, you see this reaction will also come dimensionless and this moments will be also coming dimensionless. Okay. However, when you will be putting, instead of unit load, when you will be putting a load of let us say 10 kilonewton, 30 kilonewton, something like that, then you will have dimension for the final moment or final reaction, which you will be getting from the influence line diagram. We will be discussing it later. So, now I think you are clear about it, right? So, you see, because of this, let us go to the PPT now. So, see, because of the movement of the load, now you can observe that sorry, you can observe that at different position of this, at different position of the x, you have got different values of MC. That means, you see, at x equal to 0, the value of moment is 0. At x equal to 2.5, the value of moment is 2.5. At x equal to 5, the value of moment is 2.5. At x equal to 7.5, when you are coming here, the distance from here to this point is basically 7.5. So, from here to here 7.5 distance, again this ordinate is 1.25, we have found it out. And when this distance is 10 meter from here, then you see your moment value is becoming again 0. And if you join these points with the line, with the straight line, then obviously it is going to be a straight line, because finally we will again see that like the influence line diagram equation for reaction, we will be seeing that moment influence line diagram for moments for a simple supported beam also again will come as a straight line. We will come to that later. Now, if you join these points, you will obviously notice this is going to be a straight line and then this is going to be a straight line. Now, you observe, see, if you think that a point load is acting, at just point C, that means, you see, if a load is acting over C, then you see the shape of the bending moment diagram will be also similar to this, but there is a difference, you must understand. Okay. So, bending moment diagram actually will give when the load is just position at here, then only what is the bending moment at different points of the beam. At different points of the beam, what is the bending moment because of this position of the load. On the other hand, you see in the influence line diagram what you have got. You have got because of this position of load, what is the bending moment at here? Because of this position, because of this position of the load, what is the bending moment at here? Because of this position of the load, what is the bending moment at C? Because of this position of load, what is the bending moment at C? And because of this position of here, what is the bending moment at C? So, you see there is a clear difference between bending moment diagram and influence line diagram, and you should be very clear about this point. Okay. Although it may happen that the bending moment diagram and your influence line diagram, shape of the influence line diagram and shape of the bending moment diagram may look similar, however they are totally two different things. Okay. Now, exactly the same way in the previous class, as we have seen that finding out the bending moments or the influence line, not bending moments, finding out the influence line diagram using this step by step process like this, it is very cumbersome, right? Because one by one point you will have to go, and then again you will have to find out for every point what is the reaction, every point you will have to find out what is the moment, and then you will have to plot. Instead of that, if we can find out some methodology, instead of that, if we can find out some methodology where we can represent these bending moments at C as function of the distance of the load from some end, that means as a function of x. And what is x? In the previous class we have already discussed. So let us try to understand how do I represent it in terms of x. Okay, so see, previously you have understood it, now we will see how it will be represented in terms of x. So you see, it's very simple again. So if you go back here and then you see, let us delete this one and let's see, the previous class we have started doing it, again we will discuss. See what we have seen. Suppose let's say your load is just placed at a distance, this unit load, this is a unit load, this is 1 at a distance x. Okay, it is placed at a distance x. So this distance is x from this left hand support A. So when this load is placed at x, what will be the value of reaction at A? So how do we find out? So reaction at A can be easily found out by taking moment about B. So if you take moment about B, what will happen? RA into 10, because from here to here the distance is 10 meter, in the problem it is defined, and then minus of 1, this load is 1, and from here to here what is the distance? Let's say
10 minus x.
10 minus x, very good. So it is going to be from here to here, the distance is 10 minus x. So if it is 10 minus x, then RA into 10 minus 1 into 10 minus x, this is going to be equal to 0 because we are taking moment about B. So what will be your value of RA? RA is going to be equal to 10 minus x by 10. Is it clear? Is it clear to everyone?
Yes.
Sir.
Okay. So now if we want to find out what is the moment at C in terms of x, then what we'll have to do? We'll have to take moment about C. So if you take moment about C, or you can say that summation of all the moments about C is equal to 0. So you see what we'll do? MC minus of, or in other terms also you can do this way. In the previous example, whatever we have done, see MC, if you see MC is going to be how much? This reaction multiplied by this distance. What is this distance? How much is this distance? From
5.
here to here it is 5. So MC is going to be 1 minus x by 10. Why it is 1 minus x by 10? See, this is going to be 10 minus x by 10 is nothing but, you see what I can write, 1 minus x upon 10. Can I write this?
Yes,
10 by 10 is equal to 1 minus x by 10. So it is going to be 1 minus x by 10 multiplied by 5. This distance is 5 meter, and then this load is going to create moment about this C. How much will be this moment? So see, this distance from here to here, will be how much? From here to here the distance is 5, from here to here the distance is x. So this distance is going to be 5 minus x. So this load is this red colored load is basically unit load. So this is going to be 1 into 5 minus x. So just you simplify it, you are going to get this simplified value. This is going to be 5 minus x by 2 minus 5 plus x. So 5 cancels out, minus x by 2 plus x is going to be x by 2. So is it clear? So what we are getting now? So we are getting, you see, the moment equation for C for a distance from here from here to here. That means when the load is moving between this point A to point C, when the load is moving between point A to point C, at that time what will be the moment? So basically you see moment we are getting as a function of x. So we are getting mcx basically. So if we put different values of x for this moment at C, then you are going to get the values of the influence line diagram ordinate. Is it clear? So thus if you go back again to this and you see what you are going to get, you are going to get mc equal to half of x, and you notice this will be valid for x is less than 5 meter and greater than equal to 0. That means you see from this distance, so at this point A, what is the value of x? The value of x is going to be equal to 0. Now that x will be gradually increasing, and when the x will be reaching this 5 up to this point, this moment equation will be valid. This moment equation will be valid. Very important to understand. Okay. So you see you have got one moment equation for a distance between 0 to 5. Now you see why you will have to find out another one moment equation, because you see when this load will be crossing this, C, let's say this load will be gradually coming, going, and then it will be reaching C, and then just when it will be crossing C, and then it will be moving somewhere here. So at that point you see, at that point you observe this distance will become equal to x, correct? So see at this point it has crossed the point C. So will there be any change in the reaction? Bolo? Anyone?
No, sir.
So RA is going to remain same. You see in terms of x, if you want to find out, so you will have to take moment about B. So you see you can find out the reaction using this equation only. So you see what you will have to do, this RA multiplied by this distance. What is this distance from here to here? This is 10, and then 1, this is 1, and this distance is again 10 minus x. From here to here this is 10 minus x. So 1 into 10 minus x. So RA is going to remain same. You see in terms of x, your value of RA is not going to change, right? Your RA is going to remain 1 minus x by 10. Now once this load has crossed this point C, then you tell me what will be the value of MC. You see the value of MC in that case is going to be equal to, if you do not consider this equal to 0, then also you see it is going to be equal to MC is equal to, so what you will have to do, reaction RA multiplied by this distance. So what is reaction RA? So if I write this instead of this, reaction at RA is how much? Reaction at RA is how much? 1 minus x upon 10. And what is the distance from here to here? This distance is 5. And will there be any moment because of this load 1? Anyone?
No, sir, because it has crossed the
Yes,
load.
because it has crossed the point C. Now I think the first question I have got from someone has asked that why it is like that two different equations. I think that should be clear now. So it has crossed this point C. So you see the value of MC is going to be only this one, because this load has already crossed this point C. So there is no influence of this load on the moment on C. So if you simplify this, then you see you are going to get 5 minus x upon 2. and which I have written over here. So 5 minus x upon 2. Now you see this value of MC will be valid for what? See, this value of MC is valid up to this 5. That means when this load is just at the left of this point C, just at this left of this point C, okay, then this value of MC is x by 2. But when this load has just crossed this value, just crossed this point C, and it is coming just right of this point C, then what will happen? Then this equation will be valid. So thus you see your value for this equation of MC will be valid for a distance where x is greater or equal to 5 and less or equal to 10. You should be very clear about this. So see, for finding out influence line diagram for bending moment at a particular point for a simple supported beam, actually what you are trying to find out, you have to find out two separate equations, and those two separate equations, now you observe, these are just the equation of straight line. See, this equation is the equation of straight line, and this equation is also the equation of straight line. Now if you see, if you put the values of x over here, I will be showing in the presentation. See, if you put the values of x and if you put the values of x considering these limits of x, then you are going to get the values of the ordinate for influence line diagram at different points, and that is going to be exactly the same whatever you have found out, whatever we have found out earlier using that method of step by step calculation of reactions and moments. Okay. So let us go to the slide and see. So you see now these two equations, how it is coming, you have understood. Now you see very clearly it is shown over here. See, when this load is moving over here, then why this load is, why this equation does not consider this load 1, because it has just crossed this C point. So there is no question of taking moment of this unit load when you will be considering for 5 meter to 10 meter length. Okay. Now if you plot these two equations, half of x and 5 minus half of x, and you are going to get one straight line like this. So this is actually your, you notice this is actually your MC is equal to half of x, and you see at x equal to 0, if you put at x equal to 0, what will be the value? If you put x equal to 0, it is 0. At x equal to 5, if you put at x equal to 5, you see, observe here, I have written 5 minus. What does it mean? 5 minus, just by the side at 5 minus, that means it is just, the load is just left of the C. Okay. 5 minus means it hasn't reached 5, but it has very near to C, just like this. Okay. So this is actually 5 minus, and when this load will be just crossing this and just going just right of it, then it will be x equal to 5 plus. That means you see actually what will happen, up to this 5 minus, your this equation will be valid, MC equal to half x will be valid. So you see just left of the C, if you put x equal to 5 over here, what will be the value of MC? Your value of MC will be 5 by 2 is equal to 2.5. Now when this load will be just crossing this point C, what we have shown over here, just crossing this point C, at that time what equation, which equation you will have to use? You will have to use this equation. So if you put again, you see the 5 plus, that means exactly it is crossing just 5 meter length. Then you see if you put here, so if you put here 5, then see 5 by 2, it is going to be 2.5, 5 minus 2.5, that is going to give you 2.5. Is it clear? So you see at the point C, a continuity is being maintained. That means just left of C also it is 2.5, just right of C also the bending moment is 2.5. Now when you are going to reach at x equal to 10, you see you cannot use this one, you will have to use, see if you use x equal to 10 in this equation, you see your MC value will be 5. No, your this x equal to 10 whenever you will be using, that is valid, that this limit x equal to 10 limit when we are applying, this equation will be valid. That means MC equal to 5 minus half x, this equation is valid. So you put x equal to 10, so 10 by 2 is 5, 5 minus 5 is equal to 0, so MC value is going to be equal to 0. So thus you are going to get an influence line diagram of bending moment at C in this fashion. Is this clear to everyone? Is there any doubt?
Clear.
Very important. Okay, basics you should be very clear about, then other problems you should be very well you will be able to solve. Now you see, if I go back to this problem again and I say this, instead of this point C over here, let's say if this point let's say instead of this point C over here, let's say C is now here, right? Now instead of this here, let us say if it comes over here, so will there be any change in the process of finding out influence line? Let's say C is here. So if you are asked to find out influence line of a point which is at a 2.5 meter distance from A, will there be any change in the process or steps for finding out influence line diagram? Anyone can tell? The quiz, you are going to get this question. Tell.
Sir, only the limit will be changed. Sir. Only
Very good.
limit will be changed.
Only the limit will be changed. See, the equations, other things will be remaining same, right? So you see, there is no change actually. If I move this to here, will it be any change? Will there be any change? No. Only the limit will change. If this comes over here, there is no change. So the process of finding out influence line diagram for a simple influence line diagram for bending moment for a simple supported beam for any position, for any particular position, you see the process remains exactly same whatever may be the problem. Okay. So with this understanding, let us move little further. Okay. Now let us say, so we have done it, we have taken two examples. First example we have discussed about reactions at A. So I have given one problem to you, find out influence line diagram for reaction at B. Have you solved it?
No, sir. Today I will solve.
One quiz I have given. Solve it. Okay. Solve and submit. Okay. Okay. Next, see. Let us see. Example 3. So we have understood about reaction, we have understood influence line of moment. Now let us try to understand influence line for the CR. So in this problem you will see, that influence line for shear, when you will be finding out, you will see the shear force diagram and influence line diagram for shear will not be exactly same. That you will understand. Okay. Okay, the influence line diagram for shear force, you will see it is different, and the shear force diagram for a simple supported beam, when a load is point load is acting on the beam, the shape of the shear force diagram and the shape of the influence line diagram for a particular point on the beam for the shear force is not going to be same. You will see that. Although you see in case of bending moment, you have seen the shape of the bending moment diagram and shape of the influence line diagram for bending moment is exactly same, but conceptually they are totally different, right? Now you, in this example, through this example you will be able to understand, when you will be finding out the influence line for shear at a particular point C on the beam of the beam, then you will notice that the shear force diagram, if the load is placed over this point C, and the influence line diagram of CR, when we are finding out shear for this shear at this point C, because of the different position of the load, they will be totally different. Okay. So let us start today. Tomorrow we will complete this problem. Okay. Now you see, this is the where is it? Where is it? Yes, this one. See the solution. So I am not now going into again finding out the reaction. So what is the equation of, oh God, where is it? Yes, this one. Now you tell me how do you find out shear force? So for shear force also, what you find out first? You will have to find out reaction, right?
Reaction.
So see, now we will not be again going and discussing the point in a step by step manner. Now we have understood through the problem of reaction, influence line for reaction and influence line for moment, that if you do step by step calculation for every point of the load, you are making your life tougher, because for every point you will have to do some mathematical calculation. Instead of that, what we have said, we will have to go with some kind of equation for influence line, right? So we will be, for this problem understanding, we will not be again going back and doing the same thing for your step by step calculation for your shear force. Rather, we will be going through the equation only. Let us take the Google Meet attendance now. So let us download extension, then Google Meet calendar, 25, download. Yes, done. Okay. Now see for this shear force, two equations. See, in this case also you will have to find out two equations, because you see, in the case of like the case of bending moment diagram, see, in this case of shear force also, what will happen? The load will enter first over here, then the load will move, and then it will reach this point C. So what has happened in this new problem? You see, in this new problem, this position of C has changed. So instead of the middle of the beam, the position of C has changed, and the position of C has come over here, right? The position of C has changed and the C has come over here, right? And what is this distance from here to here? What is this distance? This is 2.5 meter, right? Now you see, suppose this load is entering from this end, it is going from this end and then moving. So at some point it will be just at the left of C, and then it will move past C, and then it will be just right of C, and then it will be moving through the right of C, and then it will be going out, right? So you see, what you will have to do in this case also, you will have to get two equations of the shear, finding out the shear force. One equation will be for this distance. So one equation will be for 0 to x up to 5. So basically x is greater or equal to 0 and to 5, and the other equation you will have to find out for the other portion of the beam. So from here to here you will have to find out, right? So for the other portion of the beam, if you want to find out, then this is the distance, this one. So basically two limits, for two limits you will have to find out, and you see, for two limits, that's what we have said here, two equations to be determined, since there are two segments for influence line. Do you understand why there are two segments for influence line? Do you understand? Okay. So you see, next, if you want to find out the shear force, then what is shear force? Shear force is nothing but whatever reaction is acting and whatever loads are acting, you will have to add it or subtract it. So upward upward direction things you will have to put some sign, and downward direction things you will have to put some sign, and then subtract or add, okay, depending on their direction of load, depending on the direction of load. Now you see, you see the at a distance x, when this load is placed at a distance x from here, you see from here to here the distance is going to be again remaining 10 minus x, and for this Ra the reaction finding is not going to change, reaction is going to remain same, and you see this reaction is going to remain Ra is equal to 1 minus x by 10. Will it be or not? Tell me. Is there any confusion?
No, sir.
No. Okay. See, if you have confusion, please ask. Okay. Then you see, if I want to find out the shear force at C, if I want to find out the shear force at C, then what will be the shear force at C? So let us delete this. So for x equal to 0, 5, what will be the shear force? See, shear force is, we write with Vc. So Vc is going to be, so what is the reaction? Reaction is acting upward. So you see here also we have done it. So you see reaction is going to be Ra. So Ra is nothing but in this case 1 minus of x upon 10. Anything else will be there to find out Vc? Anything else will be there to find out Vc? How do I find out Vc? Buddhadev, tell. Hello.
So now it will be, sir, 2.1 into 2.5 minus x.
Why 1 into 2.5? Are you taking moment? It is shear force. So see, reaction is Ra. So Ra is 1 minus x minus 1 by x minus 10, and then this unit load. What is the amount of load? This is unit load. So you will have to subtract it, right?
Minus 1.
1.
That's what you will have to do. See, here also I have written it same way, right? And this will be valid for 0 to x to 2.5. So you see how much you are going to get it. You are going to get minus of x upon 10. Is it clear? Minus of x upon 10. And where it will be valid? It will be valid for 0 to x to 5. Means x, value of x when it is equal to 0, that means when this load is here, that means what is the value of x? Value of x is equal to 0, and it is greater than x equal to 0 up to this 5. And what 5? It is basically, you see, we have said it, right? It is actually valid up to 5 minus. That's what we are saying, less than 5, right? So 5 minus means when this load is just left of C up to this point, this equation is going to remain valid. So Vc is equal to 1 minus x by 10 minus 1 is equal to minus of x by 10. So this is going to be equal to, this is going to remain 0 to, this equation will be valid for this limit of x. Is it clear? Now next, next what will happen? Next you see, when this load will be just crossing this C and it will be moving somewhere here, let's say. So at the point, at the moment this load will be crossing this point C, here it is reaching, okay, or here it is reaching, whatever may be the position. So you see the value of x, the x is going to be this one, right? X is going to be this one, correct? So when this x is going to be this one, then will there be any change in reaction? Will there be any change in reaction Ra?
No, sir.
No, there is no change.
Sir.
Change. See, exactly the same thing we are doing, whatever we have done for bending moment. See, what will be the reaction? Ra multiplied by 10, Ra multiplied by 10, we are taking moment about B. So Ra multiplied by 10 minus 1 into this one into 10 minus x equal to 0. So this Ra is going to be 10 minus x by 10. So there is no change in reaction. You should be very clear about this, okay? There is no change in reaction. So Ra is going to remain 1 minus x by 10, okay? Now once you have done it, you see what will be the shear force then. So you see, for this thing, shear force for this, when this load has just crossed this C, that means when it is more than 5 or just equal to 5 and little more than 5 and up to this equal to 10, that means within this limit whatever I have shown here, you see the value of Vc. Can anyone tell me what will be the value of Vc? What will be the shear force? So shear force, you see, only will be in this case this reaction, right? Upward reaction, right? So you see, that's what we have written over here. So you see, in this case, if you observe this diagram, then you see this is your reaction, this is your reaction. So Vc is acting in this way, Mc is acting this way. On the other part, you see this load has moved over here. So what will be the reaction if you consider this portion of the free body only? If you consider this portion of the free body only, so what will be the value of Vc? Vc will be equal to Ra, okay? And thus your Vc is going to be just equal to Ra, and it will be nothing but 1 minus x upon 10. Is it clear? So thus you see, again for this shear force, influence line diagram for shear force at C, you are going to get two separate equation. One will be equation, so sorry, I think here we will have to change this, na? It will be 2.5. No one was telling me, okay? It will be 2.5, right?
Yes, sir.
So you haven't spoken. See, it will be 2.5. Limits are changing, right? Here, from here to here, the distance is 2.5. So limit will be 2.5. So you see, up to 2.5 meter, up to just left of 2.5 meter, this equation of shear force will be valid, and beyond 2.5 meter, this equation of shear force will be valid. Okay. So I think let us stop here today. Tomorrow we will discuss how to find out the what is called the reaction diagram for this shear influence line diagram of shear force. Okay. So you please submit your assignment, okay, whatever I have given. Influence line for what is called this reaction at B, I have given one problem. Okay, today I am going to ask another one problem for influence line of bending moment. Okay. Okay, so let us stop here today. Okay, thank you.
Thank you, sir.
Thank you.